Hi, I'm Noble Ackerson
Hey there, I'm Alan Furstenberg, and we are Two Voice
and
Devs.
Voice Devs.
How's it going, Noble?
Can't complain. I'm back. Definitely not
Oh,
recording on the same day.
absolutely not. We would never do something like that. But it's always good to have you back to chat about stuff.
Always glad to be here, Alan.
Last time we were here, we kind of started touching on some subjects about bridging or using AI to kind of bridge a human computer divide. And I said back then, let's hold off on that thought for another time. And I feel like this is the other time.
Yeah, you're spot on. As we were talking, it harkened back to a presentation that I believe you gave a couple weeks ago from this recording in New York. And I would love for you to sort of give us an abridged sort of, opening into that, and then we can sort of discuss that too, where computers are non-deterministic. At least machine learning as a practice is non-deterministic, right? It spits out results that we need to go back and fine tune and refine. Deep learning is the same thing. You've got back propagation, which is part of the whole process to make sure that our whatever the metric is, gets smaller and smaller as far as that number gets, our loss function gets smaller and smaller. And so when we bring that into the paradigm of large language models, foundational models, generative AI, if we want to talk about it, we realize a lot of some of these pitfalls, like what some people call confabulation or hallucinations. But it all comes down to how a human that has this sort of imperfect way of sort of communicating to a model and a computer that is more discrete. And I loved how you framed it during your talk. So do you mind sort of talking about this tension between
Sure.
language?
I guess kind of the way it's not even about language in some ways. I guess it is. I never really thought of it quite that way. But I guess I think of it more as, for literal decades, we've been saying things like, computers are digital. They deal in ones and zeros, and things have to be boiled down to ones and zeros, so they're discrete. We have our variables are integers, and they're integers of a particular size, or they're strings and the string characters are particular characters. And we do very, very precise calculations based on them in most cases. So I think of computers as very discrete. They have specific states. They are, in the end, it boils down to their ones and zeros. Humans, on the other hand, are analog. We don't necessarily think of things in those discrete terms. We can, but that's not how we deal with them on our daily basis. We think of things in fuzzy terms. We speak, when we talk to each other, we talk imprecisely in fuzzy ways. And historically, the way we've handled bridging these two worlds has been teaching humans how to be more discrete, or building our user interfaces to force humans to be discrete. You have drop-down menus that force you to pick specific items. You have buttons that force you to pick specific things. So for the entirety of computers' existence, pretty much, we've been teaching people how to talk like computers. And now, for the first time with these large language models, we've flipped that around, really. We are now teaching, and I put that in quotes, computers how to understand, and again, that's in quotes, humans.
Right.
So computers are now dealing with human fuzzy language and turning that into the discrete things that computers are used to, and vice versa, taking discrete answers
Right.
and turning them into fuzzy phrases that humans find more comfortable.
Right. And we're still not at the point where it's uncanny. In a way, for the most part, when I speak to the inanimate home device, internet connected device that sits here, I don't want to mention it for it triggers it. I can still tell that it struggles with making things as fuzzy as I'm used to, because it sort of switches personalities depending on how I'm doing that, and humans don't do that. And of course, that is probably already solved problem, but just not at the scale that makes it economically viable to make.
Right. Well, I think where this comes in with voice technology that, this show has traditionally talked about. And this is actually something we addressed a number of times when we were talking about voice content management systems, is saying you want to prepare a bunch of statements, but you want to prepare many of them to be able to take discrete results and pick one of these responses so that it sounds right to a human, and rotate between them so it sounds more natural. I think what large language models are offering us is ways to increase that randomness even more. So instead of a conversation designer necessarily having to create 5 or 10 specific responses, it can create 5 or so sample responses and let the computer, the LLM, vary them a little given other components of the response. So instead of having to create a bunch of templates, you've created a few templates and let the computer fuzzy them up a little more if necessary.
I love how you frame this by equating, just to summarize, by equating, how humans communicate and how humans understand, with that tension between how computers can communicate out and how they understand through natural language understanding techniques like LLMs and the like. I would just throw out there, just for the sake of conversation, that human computer interaction, that tension between the two, spans an integration with these tools, these new tools that we're also used to. They span other modalities as well. The mouse and the input. We basically had to train ourselves to communicate with a machine, or the touch and gestures and all that stuff.
Well,
there's a funny. Go ahead.
No, finish. Sorry.
There's a funny joke that I heard years ago about when there was this movement called the no interface movement. Golden Krishna is a former Apple employee, probably worked for Google as well at some point, and he was really pushing this no interface idea, which all the voice nerds and listening or watching will appreciate. But one anecdote that I heard another panelist say, just to talk about, agreeing with that, is the most intuitive interface ever built, ever designed, was the nipple, because it didn't require, right, if I have to explain the joke.
Minimal training, yes.
Right, minimal training, right? And so that's a zero shot, if you look at it at a baby, as it gets. It's just no inputs. It just knows natively how to do that. So it's an interesting frame, and I thought just wanted to sort of blow that up a little bit and take that to a different stratosphere, and then sort of just bring the conversation back to that. But I really enjoyed how you framed that argument, and so the next question is, how can we dive into how we solve it? You talk about that as well.
Sure. Well, I think one of the great things about this is that in a lot of ways, and as when I first had you on the show, we talked about LangChain because I was really trying to wrap my head around it. And in the months since I have, one of the things I've really started to understand is how well it caters to exactly this model. So there's a flowchart now on the screen for those that are watching it. Those that are listening, I'll describe it. It's really in some ways kind of an almost simple flowchart. It's basically, it consists of 4 parts. The first part, we need to get a request from the user in some way, whatever way that is, typing it into a chatbot, let's say. We then need to take this human language request and turn it into a computer language request. And what I'm showing here is, turning it into SQL, but that could easily be turning it into a pseudo function call, like we talked about last week, or some other structured language, or even into actual code to be executed, but that's a bad idea. But whatever, we're turning this from the fuzzy human thing, feeding it through a prompt to turn it into a discrete computer thing, running the query, executing that discrete computer thing, running the query, running the code, whatever. Then from that, we're now getting a new discrete structure. We're getting JSON, or we're getting arrays, or we're getting a table or something. And then feeding that back into the LLM with a different prompt saying, take these values, take the question. Here was the original question that was asked. Here are some digital answers. Turn that into a response that answers the question.
Right.
And in this way, and then repeat this as necessary. And I think what we found is that's incredibly effective.
You've gone from fuzzy, using SQL, a function or something that a computer can natively understand, made it more discrete. You've executed on that, turned it back into fuzzy from discrete. A human can interact with it in the way that they need, and everyone's happy. Computers
exactly.
happy.
And in some ways that seems ridiculously simple, and yet it's increasing, at least I feel like it's increasingly clear that this is a powerful tool for every programmer. This isn't this is one more tool in our tool chest now to make important programs, to make good user interfaces.
And I think it's very powerful because if you've ever followed anything that I post or write about or whatever online, it's always about data trust, right? It's the trustworthiness of some of these systems. And we talk about non-deterministic systems a lot when we're talking about deep learning, when we're talking about machine learning. We call them black boxes because who knows why it hallucinates. Right. And so at least in these early stages, I guess I'll ask this as a question. Do we feel that these approaches are only temporary as we sort of wrap our heads around sort of the attention mechanism, like there's sort of this transformer model architecture and how to interact with? Is this a new developer pattern or design pattern that we're just going to have to adapt to, or will become ubiquitous, regardless of the approach or platform that you look to use?
I think it will become ubiquitous because I think what it says is, previously we were saying things like, well, in order to do a query, you were going to need to learn SQL.
SQL, right.
Or in order to do a query, you will need to learn Python. Or, in order to calculate these values yourself, you will need to punch these into a spreadsheet and enter the formulas in yourself. Now what we're saying is this is a new method of input, and for some things, and it's more of a, you do it your way. Input that however you as a person want to input it. Do it the way that is most comfortable and convenient for you, and the computer will figure out what to do with it. And I think that's really a powerful paradigm in general.
And just to expand on that too, what you chose to use SQL as a structured way to
Yeah.
turn fuzzy into discrete, which
Well,
sort of
remember,
harkens.
2 points here. Remember, there are 2 bits of the discrete part. The first bit is the SQL itself is discrete.
Right.
So we've turned fuzzy human into a query, and that's a
Right.
discrete query itself. And then it turns it into discrete values. So yes,
Right.
I didn't mean, sorry about interrupting there, but I
No,
wanted
no.
to be clear on that point.
I see use cases where, even in education, where that SQL query itself should be considered as something that you pass back to the end user. I can see the utility of that in the corporate world for a business analyst or a VP trying to understand this, where you do a natural language search, you get your response, but then you also get the associated query that it used. That can solve some factuality problems, some data trust problems.
Yes,
How did it get to that? So
that's
it
an
helps.
excellent point.
It could be a way to sort of interpret what's happening behind the scenes as well in an intuitive way.
No, that's an excellent point. I think in that, one of the examples that I would give, and kind of what inspired this a little bit, was folks may remember a couple of months back, I did a hackathon where the experiment that I was doing was taking natural language input and turning that into a spreadsheet formula, then running the formula and returning the result.
Right.
And one of the ways that it was handling that was it would take the formula and put that formula into the spreadsheet itself. So you always had a way to go verify, well, what formula did it create for me? And audit and validate the results that way by being able to go look at what it did. So you make an excellent point that yes, one of the things that you should be doing is making available what that SQL query was, or
Right.
how did you get from here to there?
Yeah.
Taking away the black box, making it transparent, whether or not, the result itself may not need that information. If I ask you for a value, you may give me a value, but if I then want to question that value,
right,
I should be able to do so. It's an excellent point.
There are three, just to anchor on that for another second, there are 3 stakeholders that care about the messy middle process to get to the answer, right? There's the obviously the developer, right? You may want to toggle a flag, always respond with the function that you called in order to get this output, or the SQL query that was executed in order to get this output. So as a developer, that could be an arrow in my quiver to better debug or more efficiently debug a problem during that development cycle. So that's one stakeholder. Another stakeholder could be, the developers, a business counterpart to the developer, like a loan officer that wants to just sort of get information out. But for compliance reasons, they may want to turn on something on the back-end interface to say, oh, just spit out a condensed version of the log here. And then, of course, the third is perhaps unlikely, but the end user as well. There are some, I mentioned maybe a student that may want to know, is like kind of like Wolfram Alpha does, is the thing that keeps on coming to me as I think and talk at the same time. Is like, I'm not just getting the answer with Wolfram, I'm actually getting just a snapshot of how it reasoned to get to the thing. And I think what your framing of this is sort of a stepping stone to or at least one way to get to that. Yeah,
I think it's an excellent point. Is there are a variety of reasons we don't want this to be opaque.
right.
as a user, you want to make sure this is transparent. And I think you're right. It does need to be. It occurs to me, actually, one of the, what kind of started my thought process on all of this was actually one of our first conversations where we talked about vector databases.
Mhm.
And we were saying, you're taking the human input and turning it into a long list of numbers,
Right.
i.e., you're taking a fuzzy input and turning it into a discrete output.
Right.
And then taking that discrete output, doing a match in a vector database on that, coming back with matching documents, which you are again turning into discrete, into a fuzzy response.
Right.
And that was kind of what germinated some of this thought process for me.
Yeah, it's amazing, just the concept of embeddings. Like years ago, I took a course and was learning about vectors and this and embeddings, and I never once thought, I was like, well, I'm not ever going to be developing transformers or stuff like that. I will never use this ever again. But those learnings sort of help sort of wrap my head around what we talked about last time. But it's almost like what's old is new again, right?
Yes.
And we're sort of adapting old techniques to,
in ways I think, I feel like that goes back to some of the notions here is, the fact that we're turning these things into SQL. Well, SQL's been around for ages.
right.
But it means that it's familiar. We understand the risks and the pitfalls and how to deal with SQL injection and so forth. So there's already a base level that we can build on, rather than having to say, we're inventing something totally new here, and we think there are risks, but we don't know what they are. It's going to take us 5 or 10 years to uncover the worst of them by trial by fire, which is not fun. This at least gives us some assurance of some of what we're doing is safe. When I saw people who were doing things like saying, asking GPT to generate code that it then took and ran,
Mm-hmm.
I'm screaming. I'm like, who in the world does that?
Yeah, you're talking about like the baby AGI.
Yeah, things like that. It's just,
yeah.
The prompt was, write a Python function that does this.
Yeah.
And all that it did was take the response and ran the function. I'm like, that's insane. Even though it's part of this loop that I was describing, that's insane.
That's nuts. I've got a question for you before we end, though. I'm going to bring out a crystal ball here, imaginary crystal ball, and ask my friend Alan. Is what you're proposing here, at least with your New York example, where you use SQL, given the familiarity of SQL or even NoSQL, do you foresee tools like Redshift, Snowflake, BigQuery, sort of incorporating large language model tooling in the way that you're thinking?
Well,
or have they already? I have no idea what Snowflake.
I actually am not entirely sure how much they're doing so. I don't know if they'll do it in the way that I've described here. I am sure that they're going to be incorporating LLMs into some of what they do. I think incorporating it in this way makes sense, because it's also in some ways, all of these models, these are abstractions on top of another model underneath it. Right. I mean, SQL was written for managers. This is not well known. It was not written for developers. It was written for managers to be able to do queries themselves directly. Right. And it was built on top of relational algebra and indexing systems, and a lot of other components that were, required a database manager to carefully develop and tune at the time.
Right.
But you then had this SQL layer, which abstracted all of that away. And they felt it was safe to let managers loose on this. I think, we're just now building another layer on top of SQL. And that's very much the nature of how computers have evolved over time, as we keep building these abstraction layers on top of the previous abstraction layer. I'm sure we're going to see, at some point, we're going to see companies like Google enable things like connectors to your data tables, and just say, ask questions of your data table.
Right. Or if they want to prioritize features for any Amazon, Google, IBM, Redshift, like whatever database company who wants to sort of incorporate LLMs into their functionality set, I would encourage them to prioritize sanity checking the outputs that the structured outputs that these large language models sort of spit back out, regardless of what approach they use, whether it's like a functions thing like we talked about last week, or whether it's more sort of a few shot training approach to doing this. Because I'm noticing in your example, when you spoke at in New York, you have a comment to yourself to sanity check your own SQL. And
yes,
I'd love for another company to abstract that away from my workflow.
I think that's an important bit. Again, we've learned lessons about SQL injection.
Yeah.
And I think on the upside, I think since we know those lessons, we can apply them here. We just need to remember to do so. And I think increasing, one of the things we discussed last week, for example, was instead of turning it into an SQL call directly with embedded parameters, to turn it into an SQL statement that has positional parameters, and then a separate list of those parameters. Most SQL libraries handle that fine and handle that correctly and do that sanity checking for you.
Yeah.
So I think we're going to evolve in that direction more. That presentation was written before functions came out, or I might have very well talked about that instead. But I would agree. I think we're going to need to see those tools better integrated, and I think we will. So I'd love to hear what people think about this approach. I personally, I feel like this is a concrete way that developers can use LLMs to make their applications better. So I'd really like to hear what developers think about this. Am I really missing? I think this is probably one of the best ways I've seen LLMs being used. I think this is far better than examples of, answer this question in haiku like a pirate.
Yeah, it's great to demo those.
Right, that's clever.
Those make fantastic demos. But brass tacks, like when it's day to day, where do I live? I live in code. I live in trying to mold my instructions to the whims of the machine.
But more importantly, I'm trying to mold all of this so that somebody can use it.
Exactly. There's the end goal. So,
and when I think of the other important bit to kind of think about with this is that this is for any developer. This is literally any developer that knows how to use an API. So you don't need Python. You don't need to build your own specialized model. There's an API there. So if you know how to call an API, you do it with JavaScript, or you do it with Java or Ruby or whatever. And this now means that every developer now has this as another tool in their tool chest.
I'm glad you contributed to LangChain JS as well, because it seems that, you know, everything other than Python and maybe R is sort of a second-class citizen when it comes to machine learning. But Stack Overflow's report every year, I think JavaScript is one of the leading
JavaScript's still on
languages,
top. Yeah.
right? Right.
And
So
I think it's I think it's important. And we did talk about my contributions to LangChain JS in a previous episode, but I think it's important because I think making these tools available to every developer, as you put it, it's one more thing that we now have in our tools, our quiver, that we can fire with. And it's not going to be appropriate in every case, but when it is, I don't want to have some developer thinking, oh, well, if I was doing this in Python, I could, call a model, but I'm not, so I don't know what I'm going to do. We all have access to it. It's just an API now.
it's amazing because APIs birth different architectures, microservices being one.
Yeah.
Where massive enterprises, if they went the microservices route, could have different business units talking to a central service or different services in any language that they want. They want to code in Ruby, sure. Want to code in Haskell, whatever.
Yeah.
Whatever have you. As long as there was a way to interface with a RESTful API, right? And that's why we love standards.
Yep. So I would love to hear what others think. You can find us on LinkedIn. We're happy to talk about it. And maybe your inputs will I'll be able to invite Noble back another time to talk on Two Voice Devs.
Two Voice Devs.
Thanks again, Noble.
Thanks for having me. This has been fun. I really enjoyed it.